Right, so today we have three speakers. So first of all, Erich Barnstedt from Microsoft. So Erich has worked in various engineering roles at Microsoft for 20 years, initially in the Windows team and later in the Azure. But he worked in automotive and manufacturing verticals and is the founder of both Windows and Azure industrial IoT teams. Recently, he has shifted his work to support open standards at Microsoft, as well as commitments to open source and consortia work at Microsoft as chief architect. He's the author of various IoT-related patents and has a bachelor and 2 master's degree in computer science from Trinity College Dublin. So welcome, Erich. Next up,
Thank you.
Right, next up we have Sebastian Käbisch from Siemens. He's a senior key expert at Siemens Technology in Munich, Germany. His work focuses on the efficient realization and usage of standardized internet and web technologies for the industrial Internet of Things domain. Thereby, he drives strategic initiatives, research, and development for Siemens business units, such as industrial and building automation. Sebastian is an active member and contributor of standardization groups such as eClass, Industrial Digital Twin Association, and of course the W3C Web of Things. And in the latter, he is co-chair and coordinates topics around the thing description standard. So welcome, Sebastian. And lately, we have Felix Paulini from evosoft. And Felix is a software developer since 2014 with a strong interest in smart automation systems. He started with automation of software quality assurance and quickly changed to develop software solutions for optimization problems. He then developed a lot of connectivity solutions, and he got into contact with Web of Things in 2019. And actually, since 2021, he is the product owner for the Siemens inner source implementation, say WoT, and enthusiastically spreading the idea of WoT in software solutions. So, welcome, Felix. Right, I guess then with this, we can transition to the presentations. So I will stop my screen sharing. And yes, yeah, you can then take over.
And I can take over, and I say hello to everyone here in the round, and thank you very much for having us here in the community group of the W3C Web of Things. Yeah, the topic will be automated industry asset onboarding using open standard. And yeah, we got already an introduction. Maybe one guy is missing in the introduction. That's actually, we plan to have 4 presenters for this presentation, namely also a colleague of mine, Petra Mhachichan. However, we did not checked up the vacation time when we are agreed on the date of the presentation. So unfortunately, Petra is not ever able today to also be part of the presentation. I will more or less take over its part. And yeah, and all other guys was already introduced. And yeah, and I would like to start the presentation and to give you the motivation. What is it about? And I like to start why is interoperability is very, very important for different IoT solution. And as you know, there are multiple use cases out there like optimization, sustainability, and so on. That is very important to get data from the field. Yeah, and as you know, data coming from the field is not a very easy task because the field level is typical very, very heterogeneous. Yeah, so we have multiple different devices from different vendors which come with different data models, with different protocols, with different security requirements, and this is always a very big problem in today's IoT solution and IoT integration efforts to bring this information in your target IoT applications. Yeah. And when we have a more detailed look, how this look like when we say, let's take one project and we would like to use, for example, the Azure IoT stack to integrate a feed device into the cloud, and we want to see the data from the feed data, how the steps look like. And typically you do start with describing the devices on the very bottom. Then you need to do the protocol translation. Yeah, like you have to go from Modbus to Opus UA. Then you need to configure your connection to the cloud, and within the cloud you need to do a mapping to your digital twin, and then you are able to create your digital twin graph. And then finally on the top you can create your application, or you can use your application with the data that is coming from the field level device. And in between, a lot of manual steps have to be done to make this happen. And if you take an example, for example, from the manufacturing domain, then maybe it looks like what we see here. So on the left-hand side, you see some snippet from a configuration window that is be used to configure your devices. Then this information is then took to Kepware and to configure the Kepware. Then the next step is to bring this to the connection to the cloud. Here, there's already some tooling used that is doing already an automatic mapping to Opus UA here. However, when it comes to the cloud and map to the device twin, then you have also to do some configuration and so on until you go to the graph level, where you can then write your application on the top. Well, and when we go to another scenario and use a different stack, because you are using examples from the building domain, and you have to use, for example, a stack that is based on Niagara, then you will see you have to face different configuration windows, and you have to use different settings there, which makes everything complicated again, that you have to understand what I have to enter there. Do I have to copy and paste my information from the device manual in this platform and so on. And this is, I think, one of the big problems today, what we have on the market. We have a lot of integration stacks, however, which are working always in a different approach. And of course, they are also not compatible to each other. Yeah, so if you're using stacks from Microsoft or Bosch Ditto, for example, all of them, they have a different approach. They're doing actually the same steps and the same integration process. However, the developer or the user have always to understand individual how the steps looks like and how to use the steps, and they cannot be reused for other stacks. Yeah. And yeah, and the question is how we can overcome this situation. And here's a big answer, namely the Web of Things. As you know, Web of Things brings a lot of cool building blocks, which can help here to simplify the usage of this IoT stacks. As you know, it comes with a standardized device description language. It's IT friendly, it's protocol agnostic, it's extensible for any protocols. And as you know, we have already a huge community that supports this standard. And yeah, and it's providing a governance on a common ground at the W3C. And I would not suggest to go a little bit more deeper how we can benefit of the building block of Web of Things and of the technology with the thing description when we consider a concrete scenario, namely with energy meter from Siemens that's called Centron Pack. And here I would like to ask Felix to take over here and explain us here the details.
Okay, so yeah, I think Sebastian already motivated why it's a good thing to have a common description language for devices. So let's have a look at the explicit example of the PAC 4200 that we see here. First of all, we need to describe the device. That is what we've seen in our pipeline, what everybody does. Everybody does it in their own way, and with the Web of Things, we have a common understanding of how to do that. We'll use a thing description. On the left side, you can see we can just describe our device. We can describe the properties that it offers us. So easy step for, I think, at least the guys who are in this call, the guys and girls are in this call, and yeah, easy approach how to do that. And then the next step was you need to define the protocol specifics that you need to get data from the device. There's also a way to do this. For example, in the Web of Things, we have the binding templates that are describing which keywords you can use to get the data from that. So this is also fixed. Then the next step would be to enable the stacks to understand also the binding templates. This is quite an easy one since we have a JSON or a JSON LD file, which can be passed quite easily. Normally, all of these stacks have their own format of how to describe the binding templates in their case. If they would adjust to just parsing in these keywords that the standard is standardizing, we could share the description of the device and reuse it. Now, one step, or no, not one step, the next step would be that we want to map this whole device model to a common understanding. And we can use, for example, an OPC UA companion specification for this, which we could also embed in our thing description to enhance the thing description with the common understanding. We can see that here on the left side, which would mean we extend the context of the thing description and add the add type at the specific place, which would then also enhance not only the understanding, but could also, if we go to the next slide, map to maybe to the cloud protocol that we want to use, which in our example will get important. Last but not least, we had in our pipeline that Sebastian described, we want to create a digital twin. A digital twin graph, which would mean we need to understand the topology and the semantics of our devices that we have. And for this, there's also in the thing description a separate place where we can put this. I think there's some discussion around this, if this is the correct place to do it like that. But still, there is a place where we can put it, and there we can map out some relations between things. And if we have a look at the whole pipeline then in the end, which we had also in the beginning, we can enable a lot of stacks with the same model that we have created now. So let's say we have, for example, a tool like the editor, which is open source, where we can create our thing description. Every stack could share this effort, and not every stack would have to reinvent that thing. Then there are two places which are maybe proprietary or could even be shared, which is then the protocol translation and the connection to the cloud. But these can be done by any stack. And if they even share the underlying data model, like the thing description, they could even share the common understanding and share maybe some code blocks of serializing and deserializing. Then in our pipeline, we had the mapping to the device to the twin, which could be also done maybe with the editor, maybe with another tool like that is not out there, but we can base it on the thing description. So we could also share the effort of creating such a tool, maintaining such a tool, and so on. And in the end, we have the creation of the twin graph, which could be just an import in the target architecture where we want to place it. And with that, we cannot enable only one stack like we've seen it on the last slide. of Sebastian, but we can enable maybe even every stack that we have out there. Here, for example, we can enable Microsoft and Bosch maybe. And today we want to show you an example of how we can enable 2 stacks with the same thing description. Before we get to that, the interesting part that we have seen here is if we share the effort to create these thing descriptions, or the effort to maintain the tools around thing descriptions, we can share the common basis that everybody has to do. We can do this, split it up, everybody in his own stack, or we can share the effort with our tools like maybe the editor or something else. Since I don't have the Bosch stack with me, we'll start with the inner source implementation from Siemens, which is called Say What. For that, let me share my screen. Okay, so the thing we have right now is a stack called Say What, which is capable of parsing thing descriptions that you place in there and then talking to the devices. In our pipeline, you have seen the steps that were called protocol translation and cloud connection. So the Say What stack is capable of doing that. First of all, so I'm not fooling you, we only have 2 things in our running Say What instance, and no tagmeter is in here. These are just the software parts itself. Now let's have a look at our thing description that we have in here. Yeah, I think we had the example of a Siemens Centron Pack. I am using the editor here to create such a thing, and we have different properties in here which we can use to talk to that. We've also got some Modbus specifics to get the data from the device directly and talk to the device. Yeah, this is, so to say, our mapping to our device, and now we can just save that thing description to our running Say What instance, which would mean instantiating the device. And now if I go back, we have a new thing in here, which is called exactly the same like in our thing description, the title is. And if we have a look at our device, we even see that we get some data from it. And now we say we have our protocol translation finished with a implementation that is already there. But what about the cloud connectivity? And the interesting part now is if we if we have such a stack and we have this meta model, we can reuse it in different tools that are already out there to leverage some cloud connectivity. For example, what we have done is also put a time series database, in this case, a influx database, on top of our Say What stack to not only display it, but also to analyze some of the things. And if we have a look here, you can see, I already prepared that. You can see that we had no data before, and right now where I put in the thing description, we can just see the input of our total active power, which is a property that comes from our thing description, and we can just use that in our whole stack. And with that, we can even use that time series database maybe to enable batch uploading to a cloud service, so to say, or even we also have the possibility of streaming that data via some MQTT broker or so on to another cloud. And I hope now that I've talked enough. Is it already that time, Erich?
Yes, I can take over.
Perfect. Then I will hand over to Erich, who will show you how he onboards with the same thing description in his own stack to the Azure cloud, also a PAC 4200.
Correct. So first of all, let me introduce the UA Edge translator. So we actually contributed that to the OPC Foundation, but it's using the same concepts that the say WoT stack uses. So fundamentally, it's well, it's open source first of all, and fundamentally it allows you to map WoT-based devices to OPC UA. So similar to what Felix just showed, we have the same thing description here. It's also the PAC 4200. And you can see that we've added the download location of the OPC UA companion specification in the say WoT in the WoT file. And we've added one more thing to the actual mapping of the Modbus address. So you can see here, for example, we have the voltage. Here's the Modbus address. And down here, we have a new OPC UA type. So this is the type that is in a companion specification from the OPC Foundation. It's the Profi Energy Measurement Companion Specification, PNEM, and that means we can map a device that used to be just Modbus capable to OPC UA with a standardized information model. So all the types then are standardized data. So somebody who understands OPC UA and has built the companion specifications into their software can automatically understand this device. So automatic onboarding. So now, let me show you. So here is the, here's a Docker environment that I have created before. As you can see, it's Docker Desktop, which is a download. It's a licensed product, but you can download it from the Docker website. And now let me run the Edge translator. Just have to find the right command. It is this one here. So what I'm doing is I'm running two containers. The first one is the Edge translator. So this is going straight. This should be OPC Foundation, actually. This is basically just binding a port to the host. This is the standard OPC UA port 4840. So let me just run that. So I can run it on the Docker. So it's now running. You can see here it's running on the Docker environment, right? And it's bound to port 4840. So with my OPC UA client, is here. I can now simply go to localhost because it's bound to my local port, hit connect, and connect to it. Yes, it's giving me a certificate error. That's normal. So here you can see what a UA Edge translator looks like. So there is a asset management interface where you can call OPC UA methods, configure asset, delete asset, and get assets. And with configure asset, you can actually pass a WoT thing description as an argument. And then UA Edge translator will automatically look for that device on the network. It will map it to OPC UA based on the WoT thing description that we just talked about. And then the mapping will automatically show up here. So for this to work, I have another Docker application that we call UA Cloud Publisher. We can run it with this command here. So basically what it does is it says it uses the Kafka communication protocol to the cloud. It's storing logs in a certain place, and then it stores its settings in a certain place, and it binds to port 80. the port 80 on my machine, and then this is the command to download the Docker image. So I can run this. Run the same command. So now that container is running. As you can see here, we have Edge Translator and Cloud Publisher running. So now if I go to localhost, no, not like this. HTTP localhost. I can see that I'm connected to the Cloud Publisher. The Cloud Publisher is also available open source, and it allows for publishing OPC UA data to the cloud, either to a Kafka broker or an MQTT broker. And I can see here that this is actually an older version. So let me just do one thing real quick. Go to images, and I go to publisher, and I just need to pull that image. Okay, so I have the newer image now. Go back to containers. I can build this one and run it one more time. Now, if I hit refresh here, it's a newer image, and I can see there's a new Edge Translator tab. If I click on that, it actually allows me to pass in a WoT file from the local hard disk. So if I go to desktop, Siemens, this is the pack WoT file that we just talked about. So let me just make sure that this one is in fact correct, because it also includes the IP address of the device. So you can see here, it's set to 192.168.0.100. That's, however, not the right IP address on my network. So I can quickly find out what IP address I'm running. Go to my network. Oh yeah, it's because I have this dialog open. So the Siemens PLC must be somewhere in here. It's 23, I'm pretty sure. Let's have a look. 192. No, that's something else. So it constantly changes the IP address because it's DHCP. It's probably 86. No, doesn't look right. So which one is it? 180. No, that can be right either.
Interesting to see your smart home equipment.
Yes, I got a lot on here. But where is the Siemens device? Can't see it. Does anybody see it?
Should be connect to the LAN, right?
Yeah, it's 39. Probably 39. Yes, 39. So here's the actually the Centrum pack has a web interface to it. So if I go to details, the only thing that is currently getting measured is L3. So it's a 3-phase energy meter, but only L3 is getting measured. I'm actually measuring the power supply that it has. So you can see here is 240 volts, and it's getting measured. So this is the IP address we're looking for, right? So all we have to do is put this into the say WoT file here. Like so, without the slash. And then we can pass in this IP address to the Edge translator. So we pass in the file itself. Where is it gone? Desktop, Siemens. Here's the file, and then we need to basically also give it the IP address of the edge translator, right? So that in OPC TCP format. So OPC TCP : / and then the IP address is actually my IP address because I'm obviously running it on my machine. So it's this one. And then I hit send. And now it says UA edge translator configured successfully, right? So I've now basically called that method on the OPC server interface. And in 5 seconds, this thing will go dark and then reboot or restart. It'll restart the OPC UA server. And then, so it says now bad communication. So it's gone dark, and in 5 seconds, it'll come back and the Centron pack will show up here. There it is. So here we have the Siemens Centron pack now mapped to OPC UA. You can see here all the tags that the Centron pack provides are now mapped. And you can see here, for example, voltage. If I subscribe to the voltage, you can see here the values. Okay, it's waiting for data, it's taking a little, but eventually the data will come through here. So, so that's it. That's the demo. Any questions?
Yeah, thank you. I missed a little bit on the very beginning to mention that the demos are kind of spontaneous. We already did a presentation on site a few weeks ago, and of course having everything physical on the table, it was everything works smoothly there. But we have not tested before if everything is working via a web conference. But as you can see, it worked also very well. So thank you very much, Erich and Felix, for showcasing this. And yeah, I think we can now go over to the Q&A.